Mole concept. Objective: to learn the concept of a mole in relation to Avogadro's number. In our everyday life, we often rely on specific terms of amount to quickly suggest a number. For example, a dozen eggs tell us that it's 12 eggs. A gross of pencils will be 144 pencils, and a ream of paper is a bundle of 500 sheets. In chemistry, the term amount refers to the number of entities in a sample, and the unit of measurement is the mole. 1 mole is the amount of a substance that contains 6.023 into 10 to the power of 23 entities of that substance. The number in Avogadro's number, named after the 19th century chemist Amedeo Avogadro. According to the concept of a mole, the particle can be atoms, molecules, or ionic compounds. For example, 1 mole of carbon containing 6.023 into 10 to the power of 23 atoms of carbon. 1 mole of carbon dioxide contains 6.023 into 10 to the power of 23 molecules of carbon dioxide. And 1 mole of sodium chloride contains 6.023 into 10 to the power of 23 compounds of sodium chloride. Now, let's look at the concept of the mole in terms of atomic mass. 1 mole of any element has a mass in grams numerically equal to its atomic weight. This principle can be applied to all elements. Let's look at tin, which has an atomic weight of 118.7. The mass of 1 mole of tin will also be about 118.7 grams, implying that 118.7 grams of tin contains 6.023 into 10 to the power of 23 atoms. If we were to apply the concept of the mole in terms of volume, 1 mole of gas at a standard temperature and pressure will occupy a space equal to 22.4 liters. Using carbon as our example, let's do a quick recap of the 3 principles of mole. 1 mole of carbon contains 6.023 into 10 to the power of 23 atoms of carbon. 1 mole of carbon contains 12 grams of carbon. 1 mole of carbon occupies 22.4 liters of space at standard temperature and pressure. Summary: the number of representative particles in 1 mole is 6.023 into 10 to the power of 23, a number known as Avogadro's number. The mass of 1 mole of an element is its molar mass.